couple of days ago we did a drawing that had basic dimensions on it with boxes, and now let's look at what that means. It means theoretically exact. You remember the fundamental dimensioning rules from the ASME standard that we talk about when we do mechanical drafting. And rule number 1 says each dimension shall have a tolerance. So how does basic dimensioning fit in here? There are 2 ways we can tolerance a drawing. One of them is the good old coordinate tolerancing, where we use plus, minus, or limits tolerances. We're familiar with that. The other one is geometric tolerancing, where we use basic dimensions and geometric tolerances together in pairs. For example, when we put a position control on a drawing, we locate the holes that we got the position thing on with basic dimensions. So what that means is there's this theoretically exact perfect location of those holes. If you could make perfect holes, they would be there. So we put basic dimensions on them. Then the position tolerance describes how far away from true position we're allowed to vary. So position tolerances and basic dimensions travel in pairs. Here's the true position. Here's how far away from it you can vary. And we show this with a box around the dimension. You don't draw that box, by the way. You go into the AutoCAD dimension style and you make a new dimension style, as we looked at a couple days ago. You use the tolerance style that says basic, and it automatically puts the box there for you. There are actually 2 different uses for basic dimensions, and we're only going to look at the GDT application, where basic dimensions and feature control frames travel in pairs. If you are involved in maybe some fancy jig and fixture tooling design, you might use something called datum targets, and if you're doing that, then basic dimensions mean gauge maker's tolerances apply. Don't worry too much about that, but I just wanted to tell you in a minute what gauge maker's tolerances are. So if you have basic dimensions, these title block tolerances don't apply to them. Basic dimensions are theoretically perfect. They cannot have tolerances. They get their tolerance from whatever the geometric tolerance is. The basic dimension and the geometric tolerance travel in pairs. Basic dimension and geometric tolerance travel in pairs. Then here's the other application, which is using gauge maker's tolerances to locate datum targets, which are a thing where you might have just a gauge pin with a spherical tip, and you only want a certain little point on your part to be the datum. You don't want the whole surface because it's too bumpy. So GDT, datum targets. Gauge makers, people who actually make the tooling, are highly professional machinists who do extremely precise work. There is an ASME standard for the work that they do. It's ASME Y 14.43, dimensioning and tolerancing for gauges and fixtures. And gauge makers' tolerances are at another level than the ones we use on our mechanical drawings. Here is a table out of a toolmaker's handbook, which shows both inch dimensions and metric dimensions. I photoshopped it on the next slide so that you can just see the inch dimensions. I think it's easier to see. So what this is saying is, if you are a gauge maker, If this is your size range, let's say you have a 3/4 inch pin, so it lies in here. Depending on what class of gauge maker's tolerance you're using, you might have a tolerance of 2/100,000ths of an inch on up to 1/10 of a thousandth of an inch, depending on the class. When we are putting things like datum targets on drawings, we do not presume to tell them what tolerance to put on. They are by far the experts. Finally, last few slides, 3 more slides. Going back to our dimensioning, fundamental dimensioning rules, we are familiar with this rule 9. If it looks like 90, it is 90. We've done that one before. But rule 10 and 11 we haven't talked about yet, so let's talk about them now. They say if some feature is located with basic dimensions, then the features are an implied basic 90, which means theoretically exact. And if the center lines of 2 features are aligned, the distance between them is an implied basic 0. So if it looks like 90, it is 90. If it's located by basic dimensions, it's a basic 90. And if it looks like they have the same center line, it's an implied basic 0. You may never need to know that, but I want you to know that